Hey everybody, today I just want to talk a little bit about using object-oriented programming in LabVIEW for API design. So for those of you who don't know what API means, that is going to be Application Programming Interface. So essentially this is a way to create tools that are easy to use in programming language. So if I create an API that serves a specific purpose, someone else can easily use it in their code without having to go and figure out all of the underlying things that I've done. So yeah, really the goal is just to simplify development for other people. So to highlight this, I created just this kind of basic dictionary API, and this is using object-oriented programming just to kind of show some of the stuff that we can do with object-oriented programming and why that's advantageous as like an API. So just a little bit of background before I start on dictionaries. If you don't know what a dictionary is, essentially this is a way to have a list of key value pairs. So the key being just like a unique name identifying a specific value. So I could my key could be anything. It just needs to be something unique, and then I can assign whatever value to that. So for a long time, LabVIEW didn't really have a dictionary data type. So the way people worked around this was using what's called variant lookup tables. So this was a way you could basically create your own dictionary in LabVIEW using variants. Then maps were released in LabVIEW, I believe in 2018. And this is a true native LabVIEW dictionary data type. So it allows you to create basically names, unique names that map to some specific data. So this class I've created allows you to do essentially the same thing. Basically, you've got just a list of, you can add and remove and query the values of different keys and whatnot. But yeah, I can do just kind of a quick walkthrough. So if we open our private class data, I have just two things here. So this first thing is an array, and it's an array of clusters. And in each cluster, we have a tag, actually be like the key name, and then a value. And this value is a variant. So it supports, different data types. So I can pass in floats and strings and clusters and arrays and IMAC images or whatever I want to store there, I can store there. And then it has this timestamp control to store just the last time that the dictionary was updated. So you can kind of read that. So let's look. So we have this initialize dictionary function. And so here we have a constant for the class. So this was going to kind of instantiate our class here. And it's just going to start everything out. So it's going to clear out the dictionary, so there's nothing stored in it. And it's just going to take the current time and save that as last update. So this will be the first function that's always called. So we'll just drop that down to kind of start using this class. From there, I can do like a add to dictionary. And so this is going to pass in a name and a value. It's going to first here check if that name is already in the library. If it is already in there, this is going to do nothing, and it's going to return a false for successful. If the name isn't already in the dictionary, it's going to allow you to do an insert. And then it's also going to update with the current time and pass out a successful. So that's kind of what we're doing on the add side. There's a get dictionary size. So this is just pulling the dictionary and getting the number of elements in it. So we know how many things are in our dictionary. If we've got this list entire dictionary, which is just passing out the raw dictionary. We've got read key. So this is reading in the dictionary. It's looking for the specific name you've asked it to read. So it's going to go iterate through each item till it finds the one you've specified. And then, well, if it's not found, right, it's going to return an error and let you know it wasn't found. If it is found, it's going to output the variant value. And then I'm also using here this get type information function. And this ships with LabVIEW. But this is actually going to read the type from this variant. So that way, if I write to my dictionary a float or a string or whatever, it's going to return it as a variant, but it's also going to return this, which just tells me, what data type it is. So, I've got all these different options, so I can see exactly what data type my variant was. And then the other thing I have here is just a remove from dictionary. So, we're passing in a name. We're going to iterate through, see if we can find that name. If we don't find the name, we're just going to do nothing. If we do find the name, we're going to track the index at which it was found and then remove that from the dictionary. So I have a simple example so we can kind of see this in practice. So this is just a simple example VI, but just to show how easy it is to make all of this look in LabVIEW. So again, looking at why object-oriented programming is advantageous for APIs. So there's an initialize function, and there's no inputs to this, but it outputs the actual class data. So it kind of enforces you to use the initialize function first. All of these other functions, they're going to require you to input the class, and that's just coming from right here. So makes it easy. And all of these functions are, simple, pretty self-contained, and they interact with that class data the way they're intended to. So the user doesn't necessarily have to worry about, if I have a dictionary, right? How am I sharing this dictionary? How am I storing the data across iterations of loops, right? That's all handled in this class wire, so they don't need to worry about that. Yeah, so I can kind of, I've got like an add here that just allows us, so I'm only using strings for values, but right, you could convert anything to a variant, and then when you actually do like a read, it's going to output this value type that indicates what it was. So let me run this. Our dictionary at the start is going to be empty. I can input a name and a value, value 1. I can click add. I get this indication that it was successful and that demo is now stored in my dictionary. I can, add, another item to it that gets stored there. I can add, any name and essentially any value I want to it. And this just builds my little dictionary. Then when I'm ready to, I can click read key. It's going to ask me which key I want to read. So let's do the one I just barely did. Let's do Tim. It lets me know the value of that key was canon. And it also, you can see here, it output that the value type was a string. I can do the same thing with any of the other keys. So the value of demo is value 1. If I put, something that doesn't exist, right? Value not found. We get a void there. So yeah, just some of the stuff you can do. I can also go ahead and click remove, and it will remove, whatever the name here is. So if I want to remove demo, remove demo. But yeah, that's basically it. So yeah, like I said, the main goal here is just show object-oriented programming is a great way to create APIs. So these simple functions, there's only a couple here. Everything's kind of built in, to these functions, and the data is all stored through the class wire. So your developers, whoever you're sharing this code with, they don't have to worry about the nitty gritty. They don't have to worry about how to store data across different calls. It's all handled in the class wire. And all of the functionality is just built into the class methods. So I could easily create like a package that will install this API to someone's palettes, and they can just drag and drop these functions, and then you have a fully functional dictionary API available in LabVIEW. So yeah, just wanted to highlight that. One of the awesome advantages of object-oriented programming is it's a great way to create APIs. We've also talked about in some of these other videos about the benefits of polymorphism, about inheritance, stuff like that. So yeah, there are a lot of advantages to using object-oriented programming, and I do strongly agree that it is a great way to set up tools for other developers to use. It enforces them to use your tools in the way that you have expected them to be used so that they don't break them. But yeah, thank you guys for tuning in.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.